Hi, today I'm gonna talk about from the simple chemistry, in which I think I made a lot of overheads for the coordination chemistry for the college students, um, and now I'm going to do some presentation for the senior cycle chemistry. So if whichever I have PowerPoint's presentation ready, I will upload it to my page on the YouTube, and you can follow me on the Dr. Teacher. So today is gonna talk about the chemical quantities, and the most or the one of important quantity is the mole. So if we look here is the measurement of a matter, whatever matter you have, you can measure it, and of course it depends on which unit you are using. If um, if it was like few powders, you cannot weigh it with kilogram. The mass of any product or any material, you can choose a proper unit for it. So if you deal with heavyweight things, you go with a kilogram. If it was more heavy, you can measure like the weight of the car, of an elephant. You can weigh it with tons, which is 1,000 kg. If you want to go lower and you have a small amount, so you go with a gram, if you go with milligrams, and it depends. So the balance, the weight, what's the mass, we can choose which unit to measure with the weight. So performing dimensional analysis to convert between units, we have to recall Avogadro number. We apply Avogadro number to determine the number of representative particles in a substance. So now, how many particles, how many, okay, number, there is how much and there is how many. So if you want to count, you use how many for the counting one by one. So Avogadro, the scientist, he presented his number, which is the number of the atoms in a molecule, the number of moles in. So it's, we can have a look and see what's this Avogadro number represent. So we calculate particles in moles. We calculate moles using particles to determine molar mass of a substance. So measuring matter, you can see here, you can measure. There are, so chemistry, quantitative science, you perform calculations, relate quantities to the reactants in a chemical reaction to quantities of the products. So you have here some kind of pencils, cans of fizzy drinks, or copy papers, or eggs, or parrots. So you can count them. So here we have pair, we have 6 pack, we have a case, we have a dozen, we have a rem, or we have a gross. So every name, you can name the pack with different names. What is the mole? What is a mole? Matter is composed of atoms, molecules, and ions. Everyone knows this. These extremely large number of them in a small sample of a substance, so counting these particles is not practical. So if they are extremely large number in a small sample, so substance counting particles is not easy. So counting with moles. Let's count with mole. So chemists also use a unit that is specific number of particles, often atoms or molecules. The unit is called a mole. And a mole, MOL, this is the short of it, of a substance is 6.022 or 3 times 10 to the power 23 representative particles of that substance. So this is the mole. So we can have inside the mole Avogadro number, which is 6.023 times 10 to the power 23. The number of representative particles in a mole is called Avogadro's number, which is this. If we count with mole, the term representative particles refers to atom, molecules, or formula units. We even can count, we call it atoms, mole of molecules, mole of formula units. So a representative particle of most elements is the atom. So the particle we deal with an atom. Counting with moles, however, 7 elements exist normally as diatomic molecules. Let's check with these molecules: hydrogen gas, nitrogen gas, oxygen, fluorine, chlorine, bromine, and iodine. So you must memorize the diatomic number elements. So representative particle of these elements is a molecule, you see? So here what we have, sorry. Okay, so now what do we have here is representative particle of these elements is a molecule. Why molecule? So because hydrogen and hydrogen, that atom and atom bonded, it will form a molecule. So a molecule can be formed at least from 2 bonded atoms. So a simple thing is atom, and then you go to molecule. For ionic compounds such as calcium chloride, the representative particle is formula unit. We call it a formula, CaCl2. So now it's a molecule, but it's in a formula. So a mole of any substance contains Avogadro number of representative particles, or 6.022 times to the 10 to the power 23 atoms, ions, molecules, or formula units. So now this number represents Avogadro is a number of atoms, number of molecules, number of ions, number of formula units. So that's belong to a mole of it. So the mole is Avogadro number. Oh, what do you have? Is it a formula unit? So why the correct representative particle? Is it atom? Is this an atom or molecule, ion, or formula unit? So you can look H2O. What is it? Ki, O2, Ag. Let's have a look. So H2O is a molecule. Ki is a formula unit. Why? Because it contains ions. Ions. Potassium ion, iodide ion. Oxygen, diatomic molecule. It's a molecule, but diatomic. And silver is an atom. Converting number of atoms to moles. So like we take example of magnesium is a light metal used in manufacture of aircraft, automobile, wheels, and tools. Okay. How many moles of magnesium is 1.25 times 10 to the power 23 atoms of magnesium. So how many moles you have? What you gonna do? Analyze. So we know number of atoms of magnesium is 1.25. Okay, that's what's being given, but we need to convert these things or this number converted. So if 1 mole of magnesium originally contains 6.022 times 10 to the power 23 atoms of magnesium. So how many moles? Okay, we have a moles, and how many moles of magnesium is missing? We know it's been given, we've been given number of atoms. So we need to convert it to how many moles? Let's have a look. So use dimensional analysis to solve for the unknown. So we write known over 1. We drag and drop unit and chemical symbol. Let's see. So you have 1.25 times 10 to the power 23 atoms of magnesium. That's for each mole. So if we have 1 of the magnesium, how much will be for the atom? So we have to introduce 6.022 times 10 to the power 23, because this is original mole. In each mole you have Avogadro number, but we've been given number already. So okay, so now if you divide the 6, you can see, you multiply and see the conversion. So a number of moles is missing. And now you have 0.208 mole of magnesium present in 1.25 times 10 to the power 25. So what you have done, you divided. Let me have a look. If you divide 1.25 divided by 6.022. Yeah. So here, if you see the division, so I divided, so I can do this here. I can insert a text. So what I did, 12.25 because they are both, okay, times 10 to the power 23 divided by 6.022 times 10 to the power 23. Okay. Now you can see this. So the answer will be 0.22075 something. Okay. So why does this answer have three significant figures? So converting moles to atoms or molecules. Propane is a gas used for cooking and heating. How many atoms are in 2.12 mole of propane C3H8? So now we convert moles to molecules to atoms. So the number of moles we have is 2.12 mole of propane. We convert 1 mole of propane. There is Avogadro number of molecules. So 1 molecule of propane equals to 11 atoms, because we have inside a 3 carbon, 8 hydrogen, together will be 11 atoms. So a number of atoms equals what? Yeah. So dimensional analysis, we can use this. So you have the 2.12 mole of propane, which contain Avogadro number of molecules. So this is in 1. So now we have 11 atoms in 1 molecules. So you have 11 atoms in 1 molecule. You have Avogadro number in 1 mole, and we have 2.12 mole of this one. So what you're gonna do? So you get the 1.4 times 10 to the power 25. And why does the answer have 3 significant figures as well? Now counting atoms in a molecule. Okay, so okay, so we have 1 molecule of ammonium triammonium phosphate. What's inside is 3 nitrogen. So you multiply the outside parenthesis by the 1 number. So 1 nitrogen times the 3 would be 3 nitrogen. You have 3 times 4 hydrogen would be 12 hydrogens. You have 1 phosphine, 4 oxygens, atoms. So in 1 mole of this, there are 3 moles. Now listen, 3 moles of nitrogen. So we said 3 atoms. and you have 12 moles, 12 atoms, it means 12 moles of hydrogen, 1 mole of phosphor, 4 moles of oxygen. So we determine the molar mass of an element or compound. We calculate moles to grams or any gram. We calculate the grams to mole. So all conversion go first to mole. So mole, you can see here, periodic table has numbers. So the numbers, it's been written to the top, it's atomic number, to the lower is a name, to the top right will be the atomic weight, and the symbol is here. So you can see this is the general. So molar mass, the mass of a mole of an element, the atomic mass of an element expressed in grams. Now we come to weighing the element. So we can weigh the elements in grams and the mass of a mole of an element. So the mass of 1 mole of an element is its molar mass. So now you can go with mole, and you can weigh the mole with grams. So what is the conversion of mole and mass? It will be molar mass. So for consistency, we will round all masses of element for the periodic table to 2 decimal places. We don't want to go with the more than after the 0 or the point. So we just pick the 2 decimals. So for carbon, the molar mass is 12.011. So we can say it's a 12.01 gram. That's the what? The molar mass. Because it's a mole, it's a carbon, and has a weight of 12.01 gram. It's a 1 mole. For atomic hydrogen, okay, 1 hydrogen, you have a molar mass of 1.0078. So we just make it 2 decimals to be 1.01. It's approximately. So now you have molar mass. This is a new term, molar mass, and it is in you can just it's a mass, it's a weight of the atom, and with the mole. So it's a molar mass, you can say. Why are atomic masses on the periodic table not whole numbers? The atomic mass on the periodic table. So masses shown on the periodic table are weighted average of masses for all isotopes. Okay, be careful here. We have isotopes for elements. What does it mean? There is a percentage we can find this element in different isotopes. And the isotopes, what is it? The same element, but have same number of atomic number or number of electrons, same number of protons, but differ in the neutrons. And the neutron with the proton is inside the nucleus. So the nucleus will be, because of the light of the electron is very light comparison to proton and the neutron. So we sometimes ignore the way of the atom depend on the electron. We depend on the nucleus. Why? Because two particles we have inside the nucleus, and their weight is representing the atom in comparison to the electron. Electron very light. So we depend on the nucleus weight, and it's a proton and neutron. So, okay. So we could have 3 types of hydrogen. and their percentage, they differ in the neutrons, in the neutron numbers inside the nucleus. So I remember there is hydrogen 1, where there is no neutron, only one electron, one proton. You have hydrogen 1, 2, we have one electron, and inside the nucleus there is one proton and one neutron. We have hydrogen 1, 3, it's one electron, one proton, two neutrons. So these are three isotopes. Whereas you go to the carbon, you have carbon 12, carbon 13, carbon, what is it, 15? So they differ. So we can find them in the nature, but with percentage. And these, when we take the way of carbon, we can mix the three isotopes way divided by 3, if in the case of carbon, because it has 3 isotopes. And then we take the average, will be the molecular mass of the carbon. And same thing with the other isotopes. So you can see there is a little difference in the mass of one hydrogen. So you can say inside the periodic table, what they wrote the way or the weight of each element. You can say it's been written by collecting or adding all isotopes of each element divided by how many isotopes, and the average will be the atomic weight of the 3 of them, 2 of them, whatever the number, or how many isotopes it has this type of element. So now this is what we find inside the periodic table. The way of each element comes from the average of the way of its isotopes. What is the atomic mass of an element on the periodic table? Expressed in grams, the mass of 1 mole of that element. So in a gram, there is 1 gram of the element, it means 1 mole. And now we see the mass of a mole of an element. This figure shows 1 mole of carbon, sulfur, and iron. You can see to the left, the black, 1 mole of carbon atom. What is it? The weight of it is 12.01. This is the carbon. The other jar in the middle is a yellowish. 1 mole of sulfur is 32.07 gram. And what is this? It is the weight of the sulfur in the periodic table. You can find this. 1 mole of iron atom is 55.85 gram. This is 1 mole of atom. So we can say, we can measure the mole in grams. So on the periodic table, whatever weight you have for each element represent 1 mole. So now you can see here, we have the atomic weight of silicon is what? 28.5 whatever. So this is the 1 mole of it. If you select lithium, you have a 3 atomic number, and to the right, top right, will be 6 point something. That's the atomic weight. So this weight equals to 1 gram, 1 mole. It's a 6 point something grams, but equals to 1 mole. What should I take? You have a krypton here, 81, is it? Okay, I need to expand this to see exactly these small numbers. Let me take the manganese. So 25 top left will be the atomic number. 54.94 is the atomic weight, which is 54 grams. This 54 grams represent 1 mole. How many atoms are contained in a molar mass of an element? how many atoms in 1 mole or molar mass. So it is Avogadro number. To calculate the molar mass of a compound, determine the number of grams of each element. Number of grams of each element. Then add the masses of all elements in the compound. So find the molar mass of SO3. Let's see. So how many elements you have here? You have a sulfur, you have a 3 oxygen. So the mass of sulfur is, from the periodic table, 32.07 gram. That's the mass or the weight of the sulfur. Okay. And for the oxygen, 3 atoms of oxygen, what do we have? We have a 3, and each oxygen in grams will be 16. So 3 atoms we have, 3 times 16. I remember the 16 is 15.99 something. So we consider it as a 16. So 3 times 16, 48. So now we have sulfur 32.07 gram. We have 3 oxygen at 48 grams. So now molar mass of SO3 is what? You collect together or add together 32 for the sulfur plus 48. So it will be 80 gram. So this is the atomic weight or atomic weight, molecular weight. This is the molecular weight of the SO3, which is a molar mass. We call it molar mass. So we depended on the atomic weight to make the molecular weight. So 1 mole of SO3. Okay. Now listen. 1 mole of SO3 has a mass or molecular weight of 80 gram. But how many atoms there? It's Avogadro. 1 Avogadro. So in 1 SO3, it's a 1 mole SO3. It has 80.07 gram. It has 1 Avogadro number in SO3, which is 6.022 times 10 to the power 23. So this is the simplest molecule we can find from combination of sulfur and oxygen. In the case of SO3, you have 1 mole of SO3. It has Avogadro number, and it has a weight of combination sulfur and 3 oxygen, atomic weight. Molar mass, the mass of a mole of a compound. Let's check. So we have here to the left, para, dichlorobenzene, molecules or moth crystals. Okay, it's in the jar. We have this. We collected all the grams here. It's 147 grams here. Whereas 1 mole of water to the lower, 1 mole of water, it has 1 Avogadro number. H2O molecule atomic molecular weight of H2O is 2 hydrogen and 1 oxygen. The oxygen 16, hydrogen 1 will be 18. So we have 3 atoms, each way of each atom here making 18, altogether 18 grams, 80.02 gram. But it is 1 mole. 1 mole equals to 18.02 gram equals to 1 Avogadro number. We come to glucose, the blood sugar, glucose, it's C6H12O6. So when you count the molecular weight here, you say 6 times oxygen is 16, 12 times 1 of hydrogen, 6 times 12 of carbon. Altogether will be 180 gram. This is 1 mole. 1 mole contains 6 carbon, 12 hydrogen, 6 oxygen. their atomic weight, I have to calculate atomic weight, will be in total 180 grams. And this is belong to 1 mole of glucose. So the decomposition of hydrogen peroxide, H2O2, provides sufficient energy to launch a rocket. What is the molar mass of hydrogen peroxide? What is the molar mass? Molar mass. So you depend on the atomic mass of each atom, which you have 2 hydrogens, 2 oxygens. So in this case, you have 2 oxygen 2 times 16, and you have 2 hydrogen 2 times you have here the 2 times of mass of hydrogen, 2.02 gram. So together will be 34 gram in the hydrogen peroxide. So the molar mass of the H2O2 will be the 34.0 gram per mole for each mole. Find the molar mass of PCl3. Similarly, you can count 1 mole of phosphine is its atomic weight. So it will be 30.97 gram. And you have a 3 chloride. Each atomic number mass, each atomic mass is 35.45 times 3 will do 106. So 106 and 30, they will do you the molecular weight of 3-chlorine and phosphine, which is 1 mole. Together, they will do 1 mole, 1 mole. So we say molar mass of PCl3 will be 66.42 gram for each mole. Now, summary knowledge, what we have, mole is the amount of substance that contains 6 times 10 to the power 23 representative particles of the substance, which is Avogadro number. And Avogadro number is the representative number particles contained in 1 mole of substance equal to this number. And the smallest unit into which the substance can be broken down without a change in the composition of atoms, molecules, or ions. And then the molar mass, you can determine a term used to refer to the mass of a mole of any substance. Okay.